In this video, we explore Lenz's law, which is basically the set of rules that explain how does this current get induced in this loop when you change the flux, why does it get induced, and what direction is that current going to be induced. Okay? All right, so I have two ways of describing Lenz's law. Okay? And you can look at this Lenz's law slide and you see both these definitions. Okay? The first definition is a textbook definition, and it says, when the magnetic flux changes through a conducting loop or a conducting wire, right, the loop will induce a current designed to oppose the change in flux. Okay? In other words, when there's a change in magnetic flux, the loop tries to create a current that would bring that old flux back again. Okay? That is why this loop is inducing this current. It's because you're trying to get the old situation that it had before. And I'm going to make this much more clear in a moment. Okay? So that's one definition. The other definition, I call it the millennial definition, is loops of current are like boomers. They hate change and do everything they can to stop it. Eventually, this will be an outdated analogy. But another way to just look at it is that loops of current are like, older people. They get kind of set in their ways and they hate change and they do everything they can to stop that change. And I'm one of those. So anyways, here's the deal. What do I mean by this? Okay, so let's suppose that I have a magnetic field that is in to the board. Okay, and I have to be very, very careful here because I am looking at this one way and you are looking at this the other way. I have to do all these problems so that I'm explaining this from your perspective, from what you're seeing. All right? So what you're seeing in this case, okay, what you're seeing is a whole bunch of magnetic fields pointing away from you. Okay? Remember, the little X's mean the magnetic fields are pointing away. Okay? So from your perspective, there's a magnetic field going away from you into the board over here. All right? So that's what I'm going with. Okay? And let's suppose that I have a nice, healthy little conducting loop inside that magnetic field. Okay? So there's my little loop. Now it has a certain flux, right? It has a flux in this direction, right? Moving through this conducting loop. And just like any, boomer, older person, it's totally content and happy with its routine, and it likes this very much. Okay? But let's suppose that some not so nice person decides that it's going to pull out this conducting loop. And that nice warm flux that it once had, that nice warm flux suddenly goes away. It's not there anymore. Okay? All of a sudden, this loop panics. All right? It says, I want this old flux back again. Okay? I want this old flux back again that was coming in through this way. So what direction of current gives you a flux that is coming this way? Well, I want a flux. So remember that you point your thumb in the direction of the current, and then your finger wraps around the direction of the magnetic field, right? So if I want a flux coming out this way, okay, then I want a current that's going counterclockwise. Because a counterclockwise current, if I wrap my finger around it, my finger is going to come right around here and come out the board. So this current will create a magnetic flux or a magnetic field like this. Okay? And then it'll come back and around the outside and go in. So it'll be in or coming at you, right, on the outside. But it's the flux through it that matters. And so this tells us, this is the first example of Lenz's law. This tells us that if I take this loop out of its nice flux, with the flux coming in like this, it wants to create a current, induce a current from nothing that will recreate the old flux that it had. And the direction that you need is counterclockwise, because counterclockwise will have a magnetic field that comes in through the loop this way. Okay? What would happen if it were clockwise, this direction? Okay? Well, if it were clockwise in this direction, I would point my thumb here, and the magnetic field would be coming out at you instead, not this way, but in at you. So this is no good. Okay? So this is the first step of Lenz's law. Okay? The loop will create a current to create the old flux that it had. And I know this is just the first example, and it might still feel a little bit shaky to you, but we're going to do so many of these examples to make it as clear as possible. So stay tuned for more examples.